So hello guys, I hope you've been well. So today we want to do something on CAD importation and defining the motion by a curve. So in some cases, maybe it's a bushing, a spring, you might want to define the motion by a curve which has been predetermined according to your design. So you all have this by now, this mechanism here, the 4-bar mechanism. So for those who don't have, you can come and check all these points. You can redo this. So you come and click points and then data summary. Now this is for the bodies. The bodies you leave them alone. So you can come and click for the points. Data summary. So these are the points. These are the coordinates. So we want to add more points. And before we do that, we want to do this. We leave this one like that. Free body 1. And then body 0. We put 111. 111 just for the purpose of this tutorial, and also this 1 and body 0. You see body 0 where it is. We do this 111, 111, 111 like that. Now the next thing that we want to do, we want to disable these talks. So you come here, we disable all the talks that we had already done, so we deactivate them. So we right click, we deactivate like that. And then now the next thing that we want to do is to add three more points. We want to add 3 more points, point G, H and I here. So you just come here, right click, add a point. So we add point G, say apply, point H, apply, and point I. Okay, so we have these points. So we come here and we define the coordinates for G. So you put 830, 500, and 1080, and then point I. So we do this. Yes, like that. So you can come here and confirm the data summary. So these are the new points, point G, H, and I. And then for us to see how it fits, so you can easily come here. So where is that? Yes, like that. So as you can see, we have our points like that. So our body, this body 1, I think this body 1, it has moved. It has moved. I don't know which body this is. This is which body? This is free body part. It's not supposed to be here. It has moved. So we have now to change its coordinates, CM coordinates, not global origin. So I want to move it to one of the points. I think it's point 2. So let me pan this and we move. I want it to move to this point. This is point. I'm not sure, so I can just click this and then I move it there like that. So I've moved it. Then you just click this origin and then you select the point that you want. Now once you click like that, so we'll have this. So now we need to add 3 cylinders here, 3 graphics which are linked to body 1 and also through this point. So there's a way that you can do that. You don't need to cram all these points. Just right click here, add graphics. We need 3 cylinders, so apply cylinder like that, cancel. So we need like that cylinder. So body, select body 1, origin point, this point. As you can see, it's getting highlighted as you move to the next point like that. And now you come to properties, select 2, enter. And now come to cylinder 4, do the same thing. Now for the body, so body we have to select body 1 like that. And now the point, first point is this one, point G, and then the direction is this other point. Properties, put 2 like that, enter. Now you can see where body 1 is. Now body 1 is moving now because it's changing the center of mass. The center of mass is changing. So now we come here, body, this is body 1, and then point, origin point, like that, and then we come to properties, and then we say to, like that. And now once we do this, we want now to move this body. We want to move it. We want it to return to where it was. So come to not free body part. It's not free body part. And remember, these ones we must put them like this: one on one, one on one, one on one, and one, like that. I had an error when doing this part. I had to redo it again. So like that, one on one, one on one, one on one. Now once you see when you put it like that, it goes back to where we had previously defined it as. So it's not using the associated graphics, because now when we say associated graphics, this body one is associated with this cylinder, this one, and this one. Now next thing that we want to do is to come here. We can rename this. We can rename all of these. We rename them. So we rename these ones to, so you can call this the follower, and this one we can call it the coupler, and then this other one we can call it input, like that. So now the next thing that we want to do, we have all this, we have defined all, we have all the cylinders and everything. Now we come and check model. We have one degree of freedom, therefore it's not safe for us to do any analysis, because now if we use it the way it is like this, it will be analyzed as a dynamic system, which is not good. We want a kinematic analysis. So you come here to motions, motion 1, we activate like that. Once you activate this motion, we come here and we check model. Now motion removes 1 degree of freedom, and then we run this. You can just run it and then we see what happens. Close like that. Now once we do that, we come animate. We click play. We expect it to go all the way around. Yes, like that, because that was the motion that we had put this the input, so it's going all the way around. We don't want that, so we come back here. We just work on this window only. Now the next thing what you want to do is to come here. We have this motion curve. We want to import the motion data. So this column represents time. This column represents the displacement. As you can see, it's going increasing up to 1, and then now it's starting decreasing like that. It's like a sine curve like that from 0. This is the time. This is just basically the time up to 5 seconds. So let's go back to our simulation. We need now to add a curve. So come here, right click to add a curve. We say okay. We have our curve here. So we have to load that curve. So leave everything as it is default. So click that, and then we come to CAD curves, and then we come here to motion, open like that. Now once you open that, leave block 1, column 1. As you can see, this column 1, this for the X and this for the Y. Now, and then come to the Y like that, and then pick this one as column 2, and then show curve. As you can see, this is how the curve looks like. As you can see, it's like a sine curve. So we close this. Once we close that, we come now to our motion. Come to our motion like that, and then properties, we change this, we say curve, and then we check, double click that, we take curve 0, we say okay, and then we say run, close like that, and then we bring back our windows so we can return it back to normal, and then we animate, we say refresh, then we play. So expect it to go, and then it comes back down like that. maximum displacement, and then back to the origin, and so on and so forth. So that's what we expect. Now we put our output requests. We create output requests. So we come here to the output request, we add two more, apply, okay. So we want output 3 to be displacement between the ground body and the point on the other body. So we click this. So we say it's point I. We want the second one to be point I, like that. So it's this point, it's for this point, like that. So point I is here and the ground body. So now the other output here, we define it by expression. Come here by expression, click F2, come here to f of x. Because we want it to be displacement in the x direction, come here to motion, dx, properties, and then because we want it to be ground body, the distance between the ground body and the input link. Now we come here, come to the ground body, come here, we say center of mass, cm, and then you say id string, and then you add, like that. You should have this, and then you come here, put a comma, curly brackets, put your cursor inside there, and then now we scroll down to the input. So here you realize there is no cm here, but we can use the marker cm. Marker cm is the one marker center of mass. So there is no cm here. So come here, id string, add, evaluated. So you should have something like this, evaluated, say okay. So evaluated is important because it lets you know whether there are errors. Now after that, come here, we run. We run it, close, close. So we can animate again. So it will ask us refresh. And now we come here again, and then we say plot. So we want to plot various curves here. So you can come here, time, then we say body, and then we say marker displacements on follower. Then you can say dm, then we say apply. So as you can see, now this is the curve. If we say dx, so this is the curve that we have on the follower. We can come even here to expressions, then we come output 4, and then we say F2, we apply, like that. So if we come here, we can click some of the curves, and then we can highlight that one and this other one so that we see what is happening here, if it's a straight line or not. So as you can see, it's not a straight line. So this is the curve that we expect. It was because of the margins. You can do that, and then now we can animate up to the maximum, starts going down like that. So now the next thing now is importing the CAD graphics. So now we want to import these two files. We want to import them now to our model that we have here. So we want to import those CAD models, and we want the trunk of the car to be bounded to the ground or the ground body, and now we want now the lead to be on the input, like it's the boot of the car. So we come here to tools and then import CAD. So at this point, don't select, if you select this import CAD or finite with mass and inertia, you have to calculate this. You must input this before the importation is done. So you just import the model only. Unless you want to, you can do this, but you can just import like that. And then here under here, you will find that it's like this, parasolid. So select hypermesh, then come here, we select, because that we want to start with the trunk, click the trunk, we open like that, and here the output the way you want it to do. So you can say trunk graphic and then underscore FEA, we save, and then that is under output graphic. So this is how you can leave it at default, or you can just put it the way you want it to be. And then you say okay. So now we have our trunk or our body, the vehicle body. So you come here under graphics, you will have this graphic. So you want it to be underground body. Remember that. So you double click that, and then you put ground body because it's ground. It's the part of the car which is ground. Now you have to import now our trunk, our lead here. So the lead we have to, that's why you have to make sure that your 4-bar mechanism or any link, you are sure about the dimensions. Now you come here to tools again, import, and then you come here to import CAD like that, trunk lead, open, and then here you can just say, you can leave it like that, or we can change this to FEA, save like that, say okay. Now it has succeeded, so you can see it here. So you come here, you click this. Now once you click this, make sure now you put it the body as the input, because now it's the, as you can see, if we select here to come and zoom in again, it's a bit hectic, so you have to know which body you are importing like that. And now once we do that, we have that, that's okay. Now you come here to run, we say we run for 4 seconds like that, and then there's nothing else that you can do, so we say run, completed, we close, and then here we animate, and you can also plot. Come here and then we plot, so like that. So we come here to mark a displacement on follower, DM, apply. So we have this, the displacement. Remember the marker displacements that we put, you can remember them. So now we click play, and as you can see, but this is now how the boot is supposed to be. Now for us to take care of that, so we can just pause like that, we come here, we expand on this window like that. So what you want to do, you can change the visualization here by assembly, and then you can mesh it and do all that. So you just leave everything by default, assembly by hierarchy, sort by whichever you want to do. But for me, I don't want to change anything. I'm okay with how everything is. You can come and try this. So we want to track the collisions here. So we come here to tools, collision detection under tools. So you must be in hypermesh. As you can see, we are in hyper, yes, hyperview, not hypermesh. We are in hyperview. So for it to be active, for this, for you get to add collision detection. So you come here, you add like that, add a collision set. And now here we have to add components to the group. So you can click this. So group A, you can put group A. So add components, add that one to group A. And now you can click the other body, add to group B. So you have two groups. So if accidentally maybe you select this and then you add like that, you can easily, you click this because you don't want the trunk here. We don't want the trunk here. You can click this and then you delete like that. And now we come here, we say enable proximity checking, and then minimum distance, we leave it at 1. And then we check by elements. And then you say ignore collisions. So let's see what happens. We say apply, you must click apply, and then you click like that. So it will get faster as time goes. Now you can see. Let's zoom in. As you can see, like that. So you can even come here and can take a snapshot of this. And I'll use this as my thumbnail. So let's take a snapshot and then we see capture graphics area like that. Then we say collision. We save like that. Now you can also color this by, let's fit this. So we don't want to ignore, it's not supposed to go like this, so we want to set it so that it stops at collision. So come here, stop at collision, and then we say apply, and then we start this animation again. It, yeah, so we start the animation again. We want it to stop as soon as there is collision, just the way you, this is the boot of a sedan car. So we want it to stop just as soon there is collision. Boop, stopped like that at that point. Now we can come here and then we check the summary, can save this one like that, save it there. And the other thing that we can do, we can come here, we say ignore collisions, and then show result by components. So we say apply, and then now we click play. So as you can see, by components, let's see what happens. It's blue, it's safe. It's safe, it's safe. Let's see. As you can see now, the hole. So there is a collision between the lid, the trunk lid, and the car itself. So you can also do a summary of that. Now we can come here and then we take this and then we say apply. So we can start it again. As you can see, there's proximity violation here. So that's basically it. That marks the end of this tutorial. So for those who are continuing to support me, thank you very much. So but before we close, let's go to the collision that we have done. So as you can see, no incidents, no incidents, no incidents. So let's go to where there is some incidents. So no incidents so far. I don't know why it has not been. Yes, so here collision happens at 311, as you can see. And now if we do collision elements, no incidents. So if you go through this, you'll see that, yeah, primitive, it happens first at 311. So that marks the end of this video. I hope I'm helping some engineers out there and researchers.